Welcome back. In this video series by Sagar Kadam Sir Engineering Academy, let's discuss next numerical. Prove that 0 to infinity integral 1 minus cos ax into e raised to minus x divided by x dx is 1/2 log 1 plus a square, where a is parameter. Means you have understood this numerical come under DUIS. So let's start solution. We have integral I, because a is a parameter. It is a 0 to infinity 1 minus cos ax into e raised to minus x divided by x dx. Okay. So first step, by using DUIS. Using DUIS, it is di by dA is equal to 0 to infinity, as we have to partially differentiate with respect to a. So dou by dou a of that function 1 minus cos ax divided by x into e raised to minus x dx. Okay, it is as per DUIS. In that first step, we have to partially differentiate with respect to a by keeping x constant, and therefore here I have di by dA is equal to, it is a 0 to infinity, it is e raised to minus x upon x constant, because a is variable, and now differentiate only 1 minus cos ax. So differentiation of 1 is 0 minus integration differential of cos is minus sign. You know that, as differential of cos is a minus sign, but again we have differentiate ax. Keep in mind x is constant, a is variable, so differential of a is 1 into x dx. So here x get cancelled, so that we have di by dA is equal to 0 to infinity e raised to minus x into minus minus plus, therefore sin ax dx. Now this we have to integrate and we have to put limit to get value of di by dA. Now for that we have to use one formula. Which formula? That you are writing upper margin. Don't write in the same step. Write in upper margin. A formula is e raised to ax into sin bx is a formula. A formula for integration e raised to x into sin bx is e raised to ax divided by a square plus b square, right, into a sin bx minus b cos bx is a formula we have to have. Okay, so write this formula first of all in upper margin, not a part of solution. Write down this formula as a in upper margin. Note down this formula in upper margin first. So first step of partial differentiation is clear. Next step we have to integrate. Before that, note down these things with understanding, but don't forget to write this formula in upper margin. This formula. Okay? Next step. Now I have to apply this formula to this integral, to solve this integral. So as per this formula, a is minus 1 and b is a. Okay? So let us apply formula. It is a di by dA we are going to solve this integration now. E raised to, as it is ax, a is minus 1, that's why e raised to minus x divided by a square means minus 1 square is 1, b is a square, right, into a. How much a? A is minus 1, as the formula a is minus 1 sine bx, nothing but ax, because b is a, minus, as per formula minus b, as b is a, into cos bx means ax, and limit is 0 to infinity, right? So therefore di by dA, okay, di by dA, now we have to find out di by dA. So I am going to take this 1 upon 1 plus a square side by, and now put limit. As here e raised to infinity sine minus sine infinity minus a into cos infinity. Yes, here we put upper limit of infinity minus lower limit e raised to 0, as we put 0 it becomes 0, minus sine 0 minus a into cos 0. Got it? By putting lower limit e raised to 0 minus sine 0 minus a into cos 0. So di by dA 1 upon 1 plus a square, as e raised to infinity itself 0, that's why entire term 0, minus e raised 0 is 1 into sine 0 is 0 minus a cos 0 is 1. Okay, so this is 0 minus 1 into a, so therefore here we have di by dA is minus minus plus a upon 1 plus a square. di by dA is a upon 1 plus a square. So the second step by put integration and putting limit, is it clear all of you? Next step is variable separation. So before that, any doubt? So note down these things, we will understand. Next step. Now, as we have to do by variable separation, that's why I bring the dA on this side and integrating. So I am going to say by integrating. So it is a integration of di, and by variable separation a upon 1 plus a square d. So we have to integrate this. So 1 plus a square dA. So differential of a square is twice a. So I am going to use this formula for this. This formula is integration of f of f dash x upon fxx is log of that function. Log of that function. Is it right? So your function is 1 plus a square. That's why f dash x is twice a. So here I want in numerator twice a. That's why integration di. I'm going to divide and multiply with 2. So it is a 2a 1 plus a square d. So it is as per this formula. Integration of f dash x by fx. F dash x to a, fx is 1 plus a square d. So it is di 1/2. It is a log 1 plus a square plus c. As integration of di is not di, it is ia. Now to find out c, put a equal to 0. So it is a log of 0 1/2 log 1 because a square 0. Okay, is it clear, all of you? So note down this simple part first. Last step. Now it is a 0. Log 1 is 0 is equal to c. That's why c could how much? 0. So put c in that equation. So I a is equal to 1/2 log 1 plus a square plus 0, and nothing but we are I is 1/2 log 1 plus a square. So what they asked to prove, here we proved it. Is it clear, all of you? Understood? So note down this last part with understanding. Hope so you understood this numerical. Thank you very much for watching this video sincerely.